everyone, speaking with us today is Professor Bashima Islam from the Department of Electrical and Computer Engineering at the Worcester Polytechnic Institute. Professor Islam, would you like to tell us a bit more about your background in research?
Sure. Hi everyone, it's great to meet you. My name is Bashima Islam. I'll give you a little bit background about myself. I did my bachelor's in computer science and engineering back in Bangladesh. Then I did my PhD in computer science from University of Chapel Hill, North Carolina, Chapel Hill. And then I joined as an assistant professor in the Worcester Polytechnic Institute in the Department of Electrical and Computer Engineering. So the bigger aspect of my research is to focus on ubiquitous and mobile computing that includes Internet of Things or IoT, where the goal is how can we use the everyday objects around us for the betterment or development of ourselves, our environment, and our society. So what I'm going to do today is give you a very brief description of what happens in this area, what are included, how it got here, and what are we planning to see next. So I'm hoping that it inspires you to pursue a career in computer science or engineering or electrical engineering, because they are very tied in together. So I'm going to start in a very boring way. I'm going to start with the history of computing, okay? So in 1936, so a long ago, that's when the first generation of computer came into the play. And they were like super big. Like if you see in the image in the mainframe computer that was in 1936, it was a whole room, a big hall room that's full of components that just one computer. So they were big, and they were used to do a lot of data processing and large mathematical equation solving. From then, in 1966, we jumped towards having what we understand now is the path towards personal computer. So the personal computers were a little bit more personalized. So people usually use it for document processing, information sharing. From there, in 1991, the mobile computing came into the play. And this mobile came from the term mobility, so you can move. And they were mostly used for more than just processing some data or processing some information. They were working as a digital assistant. They were a communication medium like phone or text. They had location service, which we now use, like all of us use almost, for like Google Maps or Apple Maps or even Bing Maps that still exist. Then there's come as a medium of social media, information source. It also can be sensors like camera, mics, so that it becomes the part of our life. And there's a quotation I mentioned there that is from Dr. Mark Weiser, who wrote this article, The Computing for the 21st Century, in 1991. And the first line of that article is that the most profound technologies are those that disappear. That means that we, as humans, will appreciate those technologies more, which we cannot see that exist, which we won't feel like, oh, that's an extra big technology we're using. So think of how someone feels to go into that room with mainframe computers and working there. And now you are working with more sophisticated, your phone has like more power than that whole room worth of computers. And you don't feel like, oh, I'm now going to a big technology and it's so hard to use. Because it became so easy. It became so easy to interact. That's where the mobile computing became a huge leap in the history of computing. Next, around 2003, came the fourth generation of computing that is called the wearables, the cloud, the cloud computing. So there's three parts. The cloud computing is what we don't see but exists. For example, we hear about Amazon Web Service or Microsoft Azure. The websites that are being processed in the cloud, whatever we write, some online software gives us the output back. All those are happening in the cloud. The cloud computing is crowdsourcing. So we take surveys of a lot of people and make a decision out of it. Okay, in Google, we see, or Yelp, we see, okay, this is the best restaurant for pizza. That's a crowdsourcing. We are taking opinions from the people who use that. And the last one is Internet of Things and wearables, like your Apple Watch. It can be your headphone. And all of this together give the idea of smart dust, where we are saying that there will be these tiny computers everywhere. They'll do their work, but we won't actually notice them because they will be so weaved into the environment around us. So this is where the technology is now. Now the question is where it is going to go next. And that is going to be the 5th generation, which we call the generation that is coming up. There's a lot of parts in this generation of computing. I'm just going to talk about 3 very briefly. So I'm going to start with talking about earable computing. Then I'm going to go to battery-free computing, and finally to the Internet of Materials. So let's start with the earable computing, and I'm going to keep it really brief. The whole idea of earable computing is almost every one of you has a headphone. It's either over-ear, on-ear, in-ear, wired, wireless, all of you have it. Because there's like 114 million iPod that got sold only in the last year. Now, in all of these earables, these are small devices around our ears. They can be extended a little more in terms of definition. It can be anything around our head. So it can be the new glass that Facebook came up with. It can be the Bose one. It can be the Google Glass that got obsolete actually. The HoloLens, Oculus, the vision of metaverse that Meta is coming up with. So all of this, how are they going to be used? So think of that. All of these are going to have some computing, and they're going to do augmented reality, virtual reality. They're going to give us a sense of we are listening to something from different direction, even though it's just 2 earphones, like spatial sound. And I'm going to show a small video with a small example that is more about how there can be more than just augmented reality that can be enabled by these devices. So what we're going to show is, it's a headphone that has additional microphone to allow us to detect and localize a car. So we are going to see on the right, there will be a screenshot, actually a recording of a smartphone application. There will be a plot on the top where red means there is no car, blue means car, and below that we will see the direction of the car that is coming in, along with the change of the color that will indicate how far the car is. So the note that here, the idea is we are only going to use microphone because we don't feel camera is the most suitable solution here or sensor here, given the privacy factors. So let's see that. So you're going to see the color is becoming much more darker when the car is closer, and when it goes far, it becomes lighter. And we're doing this only with the microphones that we have in the headset. Okay? The last one showed like there is no car. So this is just to give you very quickly some idea of what can be done with just your earphones. The next, we're going to talk about battery-free computing, right? Now, why? Why we are going to talk about it? Why do we want to take out the batteries? So, according to ARM, we are going to have 1 trillion IoT devices. That raises a big question how we're going to power them, because 1 trillion IoT devices, if we charge them with batteries, it's going to be a lot of batteries to change. To give some perspective, if a battery lasts for 10 years, that will be 274 million battery replacement every day. You know how much that is? It's the same volume of 9 Empire State Building. So that's a lot. And where do they go? They're going to end up into the ground, into our ecology, and making our ecology unsustainable. And they're also one of the biggest burden in the growth of IoT. So the idea is, can we use or harvest all this energy around us, like the solar? What is the kinetic energy when we move? The Wi-Fi we are using. Can we use them? The problem comes in with the fact that all this energy are not continuous like a battery or a wall power. So when your computer suddenly restarts because of power outage, you see it's going to turn on the boot. Everything you are writing in the world or wherever you're in your game is going to restart if you haven't saved it already. The same problem, if it goes on and off so frequently, how will we work with that? It will just repeatedly fail. We won't be able to complete the task. So the idea is similar, we're going to save it frequently. And I won't go into details. The last idea is about Internet of Materials, which is saying the materials we use around us can also compute and communicate. So that is to fulfill the vision of Mark Weiser, because the most profound technologies are those that will weave themselves in the fabric of our life. So we always think about size, cost, and form. So a pen looks like a pen, does not look like something with a lot of things coming up just because it's smart. And the example I'm going to show you is a computational sticky note. So it's a sticky note that can even hear audios. I'm going to walk you through what's happening here. So it's like a sticky note, but the whole sticky note works as a mic. So you can talk to it and record it. Instead of writing something, you pick it up and say, hey, remind me to do this math homework at 9 p.m. It's going to remind you. So that's mostly it. That was the brief journey we have done from 1936 to 2020, where we came from a room full of one computer to a room full of 1,000 computers. Okay, and I hope you find something interesting here, and let me know. If I'll be happy to chat with any of you if you ever feel like you want to know more about this. Thanks for having me.
Hi, Ms. Islam. Thank you for your fascinating presentation about the history of computing. Now we'll move on to the Q&A. So for our first question, what sparked your interest in electrical and computer engineering?
That's not a tough question. So I would say it started when I was in my sophomore, freshman year in my high school. So it started with the fact that I enjoyed building things and making things that work. And when I started my undergraduate in college in computer science and engineering, I still remember the first big project I have done. That was a game written in C. It was very simple. There's a bunch of spaceships, you're a tank, and you kill the alien spaceships. It was called Devil Destroys the World. And to see something that you imagine come into the play and actually to feel that's the charm of this engineering, because you actually see what you are imagining. You see the success. And computer science and engineering, along with electrical engineering, gives you that additional capability, because it's not going to be so costly. It's not going to give you do not have to a lot of materials, a lot of cost to write a piece of software or to build a small embedded system. So I would say that what started the journey. And over time, I got fascinated with the fact that it's a lot more we can do and we can think that can be done with this. It's a new sort of power. You can feel yourself as a superhero once you make something.
So I believe it can be summed up that you like doing it because of the tangibility of it. So what sparked your interest in wearables in particular?
That's a good question. So this would go back to the sophomore year. The sophomore year of my college. So there is this one. Microsoft organizes a worldwide contest every year. That's called Microsoft Imagine Cup. The goal of this whole thing is can we use technology to solve some world problems? And we participated in it. I mean, I was a sophomore, me and my friends as a team. We were the national champion and world finalists with this one wearable device. So it was back in 2013, where Apple Watch did not exist yet. And we had this wearable watch, smartwatch. It was not with a display or anything. The whole purpose of it is that if someone is in distress, specifically we are focusing on pregnant women. During their pregnancies, their heart rate and their temperature changes can indicate a lot of, I would say, ambiguity in their behavior that may lead into early diagnosis of if there's some problem or not. So the whole idea was to develop something that someone does not need to think about, like, oh, I have to do this, I have to do that. It's going to passively monitor, and if there is any risk, it's going to notify the doctor and their family. So when we started this, the first plan was not to start with a wearable. It was like, okay, if something happened, how we can have something at home. Later we realized that constrains what a person can do, because if you go out of the home or in the next room, it won't work. But if you have a wearable, and a wearable that is small enough that you won't feel that you have something, that won't bother you, it enables a lot of opportunities for risk assessment, a lot of opportunities for early diagnosis, a lot of opportunities for health monitoring. So I would say my interest in this area started with that. It started with the small idea we wanted to play around, to see what we can do from it, to benefit. Specifically, we were focusing on the third world countries where internet is not widely available back in 2013. So it started from there, and over time, we worked on it for 6 months, and during that 6-month journey, we realized it has a lot more impact than we understand. It is more than just a smartwatch can be more than just a fitness band that says, oh, you have taken 100,000 steps, 10,000 steps in a day. It can be a lot more than that. So I would say that's where the inspiration came from.
Okay, so you went into the why of making wearables. So I'd like to ask you about the how now. So what is your process for making wearables?
Sure. So the way I work in, I would say the main focus of my research is working on this tiny battery-free computers. So all the things I showed you in the 5th generation, I talked a lot about battery-free computing. So I would say that is where my main focus is, that because given that these devices are multiplying, the number of these devices are multiplying so rapidly, and we need to have a sustainable solution to actually power them and support them. So one of their few challenges when it comes to working with this wearable, specifically when there's no battery. So first is it needs to be small enough so you don't realize, like, if now I take a pen and like give you a new pen, you say, oh, this is gonna see if you are writing correctly, if you make a mistake, spelling mistake and everything, but it weighs like 10 pounds, it's this thick, it has like wires coming up, will you use it for like everyday writing? Probably not. That's the whole idea. It needs to feel, for any wearable, it needs to feel like you are not having anything extra. So it needs to be small enough. Now, when you're making things small enough, you also need to think about, you have to also power it. And when you talk about ambient powering, or even with tiny batteries, it needs to have low power consumption. So you need to think about size, you need to think about power. Now, when you're reducing power and size, the problem is it also reduces the capability of the device. A big computer, like a big data center, the amount of processing power you have there is 1,000, I would say, 1,000,000 times more than what happens in a tiny computer, a tiny wearable. However, given the fact you do not want to have all this communication, there's a privacy issue, there's a delay issue, you want to do computing itself. So my research specifically focused on how you can identify which computation is worth doing and which computation we can do, so I can get feedback on time. For example, if you have this wearable that is like on Google Home and you tell it to say, hey, can you remind me to drink a glass of water I drink 8 glasses of water a day, something like that. And it reminds you, but on the next day. Do I care about it? No. I don't care if my Google Home tells me what is the current temperature is or how the weather is. 1 week after I ask, like in 1 week, the weather can go from snowstorm to rain. I don't care. So we need to know that it is timely. It meets the timing constraints. So given the timing constraint, the lower resource, how we can decide what to do, when to do, so we can serve the consumers, the user, their purpose. The reason they're using it can be used correctly. So I would say that's the goal or the gist of the research I do. I hope that answers the question.
Thanks for talking about your work and your general process. So, moving on to the perspective of a high schooler, how could high schoolers get involved with electrical and computer engineering?
Oh, that's a great question. So, I would say there's a lot of opportunities that they're to grab now. Like for example, a lot of schools, including WPI, has something called their summer program, summer outreach program, which includes, we have something called a Frontier and a Launch program, where Launch is for freshmen and sophomores in high school, and the Frontier is for junior and seniors, where the whole goal is to have like a week or 2 week worth of hands-on experience. And I actually taught this year in the summer program for one of the Frontiers, and it was really interesting to see all these people, all the junior and seniors from all around the world. We had 21 people from the US and I think 2 people outside US, and we had covered a lot of states. And WPA is not the only school who does that. Many of the schools offer this summer program. That's one. The second one is you essentially don't need a lot to start learning how to program. It starts with there is a lot of online materials. There's a lot of online, I would say, tutorials to follow through. So one thing I would say is, it's not like everyone has to learn how to code, but I would encourage to explore it a little bit to see if you enjoy it. If you do, maybe that's the path you might explore more and see if it's something you really enjoy enough to build a career on. If you don't like, okay, I hate this, that's also good. Then you know this is not the path for you. So my suggestion will be, do not take a lot of stress on, I need to get it done. I need to do this. It's more about explore the area and explore multiple areas. You do not need to just explore one thing. Explore multiple things to see which one you like, and whichever speaks to you, explore that a little bit more.
Well, everyone, thank you so much for watching our interview with Professor Islam. Take care, and we'll see you all next time.